Next, let's take a look at the digital readout. Really God's gift to the machinist world. It allows us to pay attention to the digital and not worry about constantly stopping, locking the gibs, taking the backlash out of our X and Y axis. We simply take a reference point, kind of like your GPS, off of our material, plug it into our digital readout, and we can come back to that same point for referencing. For drilling hole patterns, doing elaborate drill and tapping schemes, milling of slots, intersecting of slots, etc., the digital readout is an invaluable source on your machine. For those of you that are purchasing a used machine, many used machines now come with a digital readout. If the individual had a pretty decent working shop, he probably had a digital readout to accompany the mill. So it's an extra bonus when you're purchasing that used machine. All right, we've got a block of aluminum that we've set up in the mill vise again. The width of the block is 2 inches, 620 thousandths. The length of the block is 3 inches, 925 thousandths. We're going to insert our edge finder into the drill chuck. We're going to locate an edge and we're going to find the exact center of our block. All right, but before we do, let's assume that we went down to the mailbox and lo and behold, we received the contract from Uncle Sam to make 500,000 of these blocks. And we just jumped for joy, and we want to do it fast and economically. We're going to install what's called a production stop or a work stop on the mill vise. And that way, once we've established references for the location of our block, we can simply take one block in and out of the machine and insert the next block, provided they're the same size and we're holding tolerance, and have excellent repeatability. And this simply just clamps on to the vise jaw. Take an Allen wrench, tighten it in place, and we're going to butt one edge of it up against our workpiece. So each and every time we loosen the vise, take that block out, push it right up against the stop, we're going to get excellent repeatability. Now let's use our edge finder and come in and find the center of the block. We'll work off of the 2-inch 620 thousandths side first. We're going to take half of that, which is 1-inch 310 thousandths, plus the 100 thousandths offset from our edge finder. Remember, the edge finder is 200 thousandths in diameter. We're simply bringing it up until we contact the edge of the work. All right, we'll turn our machine on. Let's bring the edge finder up in contact with the work. Okay, and we just saw it kick off. So at that point, we're just going to back it out a little bit. Now let's go up to the digital readout. Okay, most digital readouts are going to have a keyboard associated with them. We've got 0, preset, enter, and memory. Once we've established a reference, we're just going to go up and zero out that reference. Now we're ready to establish our own reference, very similar to our GPS, finding the way back to the truck. Raise our quill, keep an eye on the digital readout. We know that our half dimension is 1-inch 310 thousandths plus the 100 thousandths for the edge finder, so we're going to move the x-axis 1-inch 410 thousandths. All right, here we go. Okay, we're sneaking up on 400 now. 399, 1-inch 400, an additional 10 thousandths. And we're done. Okay, at that point, now we can go back and establish our center 0. We'll work off of the edge now at 3 inches, 925 thousandths. Same procedure. Bring our edge finder in contact with our workpiece till we just see the offset. We're going to go back to the digital and we're going to zero the y-axis. I wish I could make the national debt go away that quick. Simply push a button. All right, so now we need to figure the distance, or the half mark, on 3 inches, 925 thousandths. Simply using the calculator, that dimension is 1 inch, 962.5 thousandths, plus 100. So we've got 2 inches, 62.5 thousandths to the center of the part. Watch our digital now. Okay, on the y-axis, 2 inches. $62.5 thousandths. Now we've plotted the exact center of our workpiece. Very, very important. Now that we've plotted that, we're going to go ahead. We've got a different hole pattern to drill based upon the center of the hole. So we're simply going to use our center drill now. We're going to go through and center drill all of our holes. Then we can come back around and drill the holes from there. Again, the advantage of the digital readout lets us keep track of where we're at without constantly locking down the ways, adjusting the dials and the lock nuts. We simply use the digital readout and we're ready to go. All right, let's use this as a reference. Going to drill our first hole right in the center. We are going to index to the left on our x-axis 3/4 of an inch. So 0.750. Remember our decimal system from our earlier review. Okay, now we're going to move on the y-axis 1.5 inches. Okay, there we are. We've offset 750 thousandths on the x-axis. We've moved on the y-axis 1.5 inches. We're now ready to come down and center drill another hole. We're going to index now over on the x-axis to the right, back to center. Watch our digital readout now. Okay, we're now at 0, back at our original setting, 750 thousandths. You can just sit there and watch the numbers grow. Okay, we're ready to center drill another hole. Move down. Okay, now we're going to come in, center drill our third hole. We're going to index over to the left now for our final hole. Presto changeo. We've now located 4 holes, actually 5, from our center reference all the way around the periphery of the block. We've center drilled them. If we're going to drill and tap or put in a larger drill, we simply do so at this point, and again, we can chase those hole patterns all the way around the block. Keep in mind, as far as time is concerned, if we have a long distance between holes, we're better off from a time standpoint to simply go in, drill, ream, tap, whatever we're going to do off of that one position rather than chase the holes all the way around a rather large part. Okay, finish the operation as you go. That way when we get to the last hole, we're done. We're not continually chasing our tail. Now, if we want to go back and reference the center of our part, we're going to mill a square around the center of the part. So we'll simply watch our dials again. We're going to locate back to the center of our part. Moving the y-axis now. Now we're moving the x-axis. We're going to reinsert our center drill and come back. Watch closely now. We're in the exact center of our hole. We're now ready to remove the center drill, remove our chuck, and let's go ahead and mill a square around that part with a designated offset. Okay, we're going to offset our square 3/4 of an inch from the center of our hole. We simply move the x-axis over 750 thousandths. Okay, we can lock our table down at that reference. Start our cutter. Come in contact with our workpiece, establish a 0 on the z-axis now, so we can cut that slot to a specific depth. We're using a 2-flute center cutting end mill. We can cut that slot to a depth of 100 thousandths. Now, from that 0 setting, we're going to want to go 3/4 of an inch each direction. So very carefully advance our slot. $750, come back the other direction. $750 thou, loosen our gib. Going to move the x-axis. We're going back to 0 setting now. Okay, we're at the center of the part. 750 thousandths, the other side of it. Okay, now we're going to lock down our quill and go the other direction. Now we'll move back to our original slot. All right, let's get rid of the chips and uncover a masterpiece. All right, there we have it. We've in essence built a moat or a cooling passage around our particular part by the use of the digital readout. A whole lot easier and faster than we could by trying to keep track of the revolutions and dials, backlash, etc. So as you can see, the digital readout is really a gift. It enables us to perform our tasks much faster than we would with the hand dials. Read the booklet, get familiar with it, do a few simple layout patterns on a piece of material, and become familiar with it, and you'll find that it's the best friend you'll ever have on the milling machine.